everyone, this video is about the laws of surds. So let's get started. Now first, before looking at the laws, let's look at this right here. So this is how you write a surd or a root if you want. So this part under the symbol, this part is known as the radicand. Okay, and then this symbol itself, it's the radical symbol. You don't need to know this, but it's good to know about it, just in case, in a question it pops up in words. This is the degree. And this entire thing is a radical. Okay, sounds fair. I think if you know about this, then it's easier to understand the operations. It's not like you need to memorize it. It's nothing difficult, radical symbol, but it's just better to know about it. Now let's look at the first law. The first law is if I have an exponent and I raise it to a fraction. Now, the one thing you should know is that surds and exponents are connected. They're very, very similar. So if you watch my videos about the laws of exponents or you know about it, then a lot of the laws you see here are going to be very familiar. So if I have a raised to a fraction, then that becomes the root of a, the mth root of a. So whatever I have in the denominator is going to be my root. So if I have, for example, if I have 4 raised to the half, then that's going to be the second root of 4, which is the square root of 4, and that's going to give me 2. Okay? If I have, say, 5 raised to the 1/14th power, then that's going to be the 14th root of 5. So whatever I have in the denominator, that's going to become my root. Okay, but this is only true when there's 1 in the numerator. Because there's 1 in the numerator, we're kind of just ignoring it. We're just taking the denominator into consideration. But what if I have a raised to m over n? What if n is a value which is not 1? Then what is going to happen is I'm going to get a to the m, the whole thing with n. So this law still applies. My denominator is going to be my root. So here n is the denominator and n, I'm going to get the nth root. But the numerator becomes what I raise my base to. This is the same thing as n, the whole to the m. So if I want, I can raise the m to just the base, or I could raise it to the entire thing. Now this is something you should know, because depending on the problem, you'd want to use one or the other. Let's look at some examples so you know what I mean. If I have 8 raised to the, let's say, 2/3, right? Then I could either write it like this, so my 3 becomes the root. I could have the cube root of 8 squared, or the cube root of 8 the whole squared. Now, if you notice, 8 squared is 64. Finding the cube root of 64 is harder than finding the cube root of 8. The cube root of 8 is simply 2. And then raising that to the second power gives us 4. So in this case, you see that using this law here, or this form of the law, is much easier. So depending on the case, you want to use one or the other. But you need to know that both of them are exactly the same. They're telling you the same thing. Let's move on to the next law. What if I have two bases, a times b, and the whole thing is square root? And this is very, very similar to the exponent laws, where you can simply multiply them out and raise each one individually to the power. So if I have the square root of say 10, that's going to be the square root of 5 times the square root of 2. Okay? If I have the square root of 20, that's going to be the square root of 5 times the square root of 4. And when you can simplify it, you can. So 5 fours are 20, but the square root of 4 is 2. So that's going to be the square root of 5 times 2. And then you usually write the multiplication sign in front. That's going to give me 2 root 5, okay? And when you have a law dealing with multiplication, you can expect to have the same law dealing with division. It's kind of like milk and cookies. When you have milk, you expect to find cookies, but that's not all the time, right? You don't have to always have cookies with milk. So it's kind of like that. I know it's a bad analogy, but I think you get the point. So when you have something with multiplication, you find a very similar law with division. So here we multiplied them out, but here if we had a divided by b, the nth root of a divided by b, then that's the nth root of a divided by the nth root of b. So if I had the cube root of 20, let's make that 27 over 64, then that's going to give me the cube root of 27 over the cube root of 64. The cube root of 27 is 3. The cube root of 64 is 4. So I'm left with 3 over 4. So this is basically what these two laws are saying. Let's look at the last one. Now this might be a little confusing to look at, but let's go over it. So if I have the nth root of a base, and I raise that to the same value n, then that's just going to give me 8. Now if I go back to this law here, right, if I have base a and I raise it to m over n, then whatever is in the denominator is the nth root, and the numerator is what we raise the base to, right? We're doing the same thing over here. So if I have something, the nth root of something, and I'm raising that to n, we can write that as a to the n over n, right? And when we have n over n, or any fraction, if I have 243 divided by 243, those just cancel out to give me 1. So the same thing, if I have n over n, that cancels out to give me 1. A to the 1 is a, and this is again depends on the exponent law. If you know that anything raised to the first power is just a, because all I'm saying is, so if I have 17 raised to the first power, that's equivalent to 17 times 1, which gives me just 17. So anything to the first power is a. So that's basically what this law is saying. Let's look at an example. If I have the 5th root of, 333. Okay, the whole thing raised to 5. This is the same thing as 333 raised to 5 over 5. So the denominator 5 becomes the root, the 5th root. Sorry, make sure I write this inside the root sign. Make it more accurate. So the 5th root, the denominator becomes the root, and the numerator is what I'm raising it to. So it's 333 raised to 5 over 5. That cancels out and gives me just 1. So my answer would be just 333. Okay, and this is exactly the same thing if I didn't raise it over there. If I said the nth root of a raised to n like that, if I just raised the base and not the entire thing, that would still give me 1, because we're doing exactly the same thing. We're raising our numerator to the base and the denominator as the root. Okay, so these are the laws of Surds. They're quite easy. They depend on, or they're closely related to the exponent laws. And if you know these, then solving questions is going to be very easy. Thank you, and catch you in the next video.